Welcome back to the L20 programming class with section number 4. Today we're going to talk about T codes and M codes that we use on the L20 machine. T codes are used to select and position tools. It has a format with the letter T following with 4-digit number. So you can call the tool with or without the object following the demand like this right here. But if you're using the letter T with only 2-digit number, and then that will use to call the offset. And then T with the letter 0 is going to use to cancel all the offset. Following with the T codes, we have a lot of arguments, and depends on the location of the tool, we're going to have the different arguments. So right here we have the tool number 1 to 13 on the main gang, and we have this much argument right here. First we're going to talk about X, Z, and Y argument. So if you have X, Z, and Y argument after the tool call, first the tool it will wrap it above the bar stop, and then it will go to the position that you command right here. Alright, if you're gonna add Q1 right here, which is we have argument right here, the machine, it will force the tool to go right straight to position where you command right here. And then it's really dangerous because the tool, it will not move up on the X first, it just go right straight to it. So be careful when you use the Q1 argument. H argument. Whenever you use the H argument with the tool call, the machine, it will wrap the current tool to the stock side plus whatever the value that you put right here, and then it will index the new tool. K2 argument is used to control the tool on the main gang in order to work for the sub-spindle side. E argument. When you use the E argument together with the tool call, the tool, it will index at the same time with the C1 axis position with E value that you input right here. R1 is used to call the same tool, different tool in the same holder. Example, if you have the holder like this on the station 9 and you have 3 tools, so the first tool right here is going to be T0900. The second tool is going to be T0900 and R1. And this one is going to be T0900 R2. A argument is included. A1 and A5 is used in order to allow the tool hit and 0 data in G660 mode. So A1, it used the front side data in order to control the center of the program. A5, it used the back tool data in order to control the center. Whenever you command M1 with the tool call, the machine, it will not read the highest tool set clearance, and it will index to the next tool right away instead of moving up to clear the longest tool before it index. So this might save you some time for a cycle, but it's really dangerous, so be careful when you use it. Alright, next gonna be tool 51 to 54, which is the tool on the gang but it's working for the back side. We have a lot of argument right here too. Some of them will repeat and I will not go over it again. So right here also. But right here we have Q1 and Q3 and W. So Q1 is also working the same. We'll force the machine to index the next tool without moving the Z back with this amount. But if it's omitted, and then Z will move back with this amount right here. Q3, it will force the Z to go back home before make the tool change. And W right here, whatever the value that you input, the Z2, it will move exactly the same amount before it indexes to the next tool. Front ID work with the tool from T21 to T26. I'm going to skip all the repeated argument and then go straight in the S argument right here. The normal tool set 0 is about 10 millimeters away from the face of the back spindle chuck. But if you have a tool, a ship tool, is set longer than the normal way, and then you're going to use the S argument in order to change the position of the Z2 when calling the tool in G610 mode. The argument on the back ID tool is pretty much repeated the same, so I will not go over it again. But then one thing that you should pay attention right here is you cannot put the offset together with the tool 20s and 30s because the machine, it will not recognize it. Now we're going to jump into the M codes. I'm not going to go over the whole list, but I will go over some that I believe is really important for us, to use later on for programming. The first M code I'm going to talk about is the M8. M8 is working as end-up bar switch in order to control the block delete right here to allow the machine in order to read the bar loader subprogram or not. In the program, we always see two M8 right here. The reason why is the first M8 is going to read the bar end signal from the bar loader. The second one is going to confirm the first M8 to see if we're going to turn off the block skip right here to read the bar loader subprogram or not. And then M9 used to cancel the M8. The next M code I'm going to talk about is the M320 right here. It used to control the part catcher to move it forward in order to catch the part. It has a lot of argument right here, but I normally don't use this argument except for the X argument right here, because it helped me get less chips in the part catcher. The reason why is I can control the X1 axis to where I'm going to bring the part catcher forward. Next going to be M33. It's a part ejection from the sub spindle without knockout. So it's working similar to the M34, but it doesn't dump the part into chute. So you can create your own unique way in order to save cycle time, or you can have a special ejection routine. And we have the M34 right here working as the full cycle for the part ejection. Now we have M50 is working as a cutoff tool break detector by checking the rotation of the sub spindle. So we have an example right here how to use the M50. At this point of the cutoff, after it's done, we turn off the main spindle and the sub spindle. After that, we cancel the sync. So if the part is already separate from the main spindle, then we turn on the main spindle right here. The sub spindle is not supposed to turn on. So if it's turned on, the M50 right here, it will catch it and say, okay, the cutoff is broke, and then check it. And we have another tool break detection using a switch controlled by the M50 right here to physically checking for the part if it's already separate from the main spindle or not. Next, we're going to have interference checkup. So in the back ID tool, you're going to have the tool sticking out with different length like this. When you have the sub-spindle come in and try to work with this tool right here, the machine will see, okay, you trying to get into the danger zone, you might have interfere with this tool right here and here. So it will stop you from doing that. But if you see you still have clearance for the sub-spindle come forward to work with this tool, you're going to use M88 in order to turn off the interference. So it will allow you to come forward and working with this tool right here. And then also after you're done, you're going to use M89 in order to turn the interference check back on. M98 is used to call the subprogram. If you have the subprogram attached together with the main program, then you're going to use the H argument right here with M98H and the sequence number. If you have the subprogram that's separate from the main program but it's still inside the machine memory, then you're going to use the P argument right here. And what you're going to do is M98P with the subprogram number. The D1 argument is used to call the subprogram from the flashcard. So what you're going to do is you're going to do comma D1 right here in order to run the program on the flashcard. The last argument is going to be L, is how many times you want to run the subprogram when you use the M98. So for example, if you have right here L5, that means you're going to call the subprogram 1111 and run it 5 times. And M99 is used to return from the subprogram back to the main program. On an old L20 machine, we use M140 in G610 mode to bring the 220s up all the way to the front of the guide bushing. Usually the position is Z2 equal 7.0866, but you can change the position of the Z2 by using the Z or W argument right here. And M141 is used to bring the sub-spindle back home, or you can change the position also as well with Z and W right here. That's all the M codes that I want to cover in this video. I hope you enjoyed it, and then follow for more topics in different videos. Thank you and bye bye.